Hi, in this video we'll be going over some worked examples for the perpendicular bisector locus. So the first question we'll do is sketch on an argand diagram the locus of the point xz equals x plus yi, which satisfies the following conditions. And our conditions will be z plus 2 minus I is greater than or equal to z plus 1 minus 2i and imaginary part of z is greater than or is less than or equal to 2. So let's start. So we've got our argand plane, and what we can first do is plot out our 2 points. So these points are actually, if we flip the sign here, so we actually have, on the side we have, I'll just put this in brackets, z minus negative 2 plus I. So that's our actual point here. So that's our actual point there. Z minus negative 2 plus I, so that's this here. So we'll put negative 2 plus I, put that about there. And it's greater than z plus, here, let's just draw this over here. So z plus, we'll do z minus, oh hang on, I haven't written this out right. Oopsie. Z plus 1 minus 2i. So that's z plus minus negative 1. And then plus 2i. There we are. Cool. That's our second point. Negative 1 plus 2i is our point here. So negative 1 plus 2i, we'll put it up here. So what is this? So this is just a perpendicular bisector here. So the perpendicular bisector goes exactly between these 2 points. So it'll go, if we get our ruler out, let's position this right. Should go about halfway through here. So we'll go about this way. Like that. Somewhat like that. And our second condition is the imaginary part of z is less than 2. So we can also draw a line, bring this up, less than 2. So that just means up here. So we need to draw one at 2. We can start with one at 2. And let's just add arrows on these. Arrows here, and there, and there. Let's just label our graph because we haven't done that imaginary aerial. So what does this mean? It means that the locus needs to be less than this half of the bisector and also less than this. So this locus just refers to the area shaded in here. Oh, that's kind of messy. Let me redo that. This area in here. And once again, how do we know that? Because this part here, plus 2 minus I, is this side, plus 2 minus I here, is greater than that, so it has to be on this side of it. So x is greater, so it's over here. X is less than, so it's over this side. And it's also less than 2, so it's down here. It's not above this horizontal line there. So that is that first question. That would be the answer to this question, drawing out this locus with these conditions. Now, second question. Let's just fix that canvas. Second question. All right. Our second question might be to find the Cartesian equation of the locus described by z minus 4 plus 3i is greater than, oops, sorry, no, not is greater than, it's equal to sorry, z minus 3 plus 3i. Okay, 3i. Now what we just need to do is first thing we'll do, as always, let z equal x plus yi. Okay, z equals x plus yi. Now we'll write it out, and what we're going to do is we'll just group real and imaginary terms as well. So we have x minus 4 make sure we put all this in brackets, by the way. So then we have to change the sign of this. Minus 3i. Put this in brackets. Change this. Alright. X minus 4. And then that would be y plus y. Plus y. Minus 3 equals z minus, oh, not z, my bad. That shouldn't be a, oh my goodness. And that should not be a curved bracket, that should be a line here. Should be x minus 3 plus, oh gosh, this should be imaginary, sorry, plus y plus 3. Y plus 3 just realized that the sign needs to be wrong. This sign was wrong up here, so this actually is a plus in here. So this should be y minus 3. That's why that's that. And then the rest of this is all correct. I need to put a bracket there. Yep. Cool. All right. So let's take this into Cartesian form. So we'll figure out the modulus. So x minus 4 squared. X minus 4 squared plus y minus 3 squared equals, and we can just get rid of the square root to the next step when we expand it. So we'll be doing that x minus 3 squared. Remember the I sign disappears. Y plus 3 squared. So what does this simplify out to? If we expand it all out, that's x squared minus 8x. This could be done on a class pad if you want. Plus 16 plus y squared minus 6y plus 9 equals, and the same thing on the other side, x squared minus 6x plus 9 plus y squared plus 6y plus 9. Alright, so let's cancel some terms. Cancel the x squareds, we can cancel that 9 there, and that 9 there, and the y squareds, that y squared and that y squared. So we're left with, let's move terms to similar sides. So we can move this negative 8x over to here. So we have equals 2x on that side. Move the 6y over to this side. So we have negative 12y. And 16 over to this side. So 16 and 9. That would be negative 7, I believe. So then y would be equal to, divide out by 12, negative x on 6 plus 7 over 12, and that would be the Cartesian form of this here equation. All right, those are 2 work examples. If you have any questions, feel free to contact us using the contact form on our website, and have a fun time learning your loci.